All right, so today we're going to talk about Algebra 2 Lesson 10, solving and graphing inequalities. And I'm hoping that we're fairly familiar with a lot of this. An inequality is a mathematical statement comparing quantities that are not equal. And there are four inequality symbols that you should be familiar with. How many of us are familiar with greater than, less than, equal to, less than or equal to, greater than or equal to? All of those things. All right. And granted, there's kind of corny little ways to remember these things. We always read it from left to right. So, if I've got something like, let me find a marker here. We're reading that as x is less than 5, right? Okay. If I look at it if I switch that, I'm not reading that as x is greater than 5. I'm reading that as 5 is less than x. Does that make sense? Okay, we read it from left to right. So this is always less than. It's not dependent upon where the x is. Now, granted, we would like to keep the x on the left-hand side. All right. It's just the same way we would do x equals 5 or something like that. We don't like to read it as 5 equals x. We want to read it as x equals 5. So hopefully we understand that these symbols don't really change, that less than is less than, greater than is greater than. The way I don't know, somebody whenever I was in school told me that if you have a hard time remembering what is bigger and how it should face, that they always described it as what, like an alligator? Alligator always, is going to try to eat the biggest thing, something like that. I always thought, also, bullies always pick on the little kid, so you can almost, what do bullies do? They point at people and they laugh, so always kind of pointing and picking on the little guy. So, I don't know, whatever works for you, whatever's going to help you remember it. And then, of course, the little bar underneath our symbol means what? Equal to, meaning that that number is included in the set, right? As we look at how do we graph these things on a number line or how we graph them on a coordinate grid, all right, that's going to tell me whether or not my line is included or excluded, or whether on a number line if my number is included in that set or excluded from the set. So solving an inequality is similar to solving really any type of equation, meaning that I can still move things left and right across the inequality. That doesn't change. But as we look, there are some other properties, some other things that happen, some specific situations that we want to be aware of. For instance, if I divide by a negative or multiply by a negative across an inequality, can anybody tell me what happens? The inequality symbol changes directions. You're absolutely right. Now, if it was equal to before, it's still going to be equal to. We don't get rid of the equal to or add an equal to, but really that's kind of the big deal. Is if I'm adding or multiplying by a negative where I'm moving that across the inequality symbol, that changes. Other than that, a lot of times you can treat it just like it was an equal sign, right? Those are really your only two property rules that are you have to be aware of. The properties used to solve inequalities are similar to those when solving any other equation. Okay, all the values that satisfy the original inequality make up the solution set. So we have these properties of inequalities, things you're probably already familiar with. Addition and subtraction. If A is less than B, then A plus C is going to be less than B plus C. Right? Because if C is C, it doesn't matter. A is less than C. So if I had something like, I know A is, if A equals 5, right? And let's give it something, B is 6, then, if C is, C is 3, then it doesn't matter. 5 plus 3 is still going to be less than 6 plus 3, right? 8 is still less than 9. So as long as A is less than B, then if I add the same thing to both of those, I'm still in the same ballpark, okay? And the vice versa, it's also true of subtraction, because 5 minus 3 is still smaller than 6 minus 3. Well, 5 minus 3 is 2, 6 minus 3 is 3. It's still less than. Okay? So if A was smaller than B before, if I add or subtract the same thing from both sides, my inequality symbol does not change directions. Okay? All right, looking at multiplication. Okay? If C is less than 0 and A is less than B, well, what is something if it's less than 0? It's a negative number. So basically what they're saying there is if C is a negative number and A is less than B, then A times C is going to be greater than B times C. Okay? And A divided by C is going to be greater than B divided by C. Let's go ahead and let's kind of keep using our illustration. Let's say, what did we say? A was what? 5. B was 6, right? And C was what? Well, actually, we'd have to say, let's say in this case, it's -3, right? Because it's got to be less than 0. All right? Then 5 times -3 is what? -15. And -15 would be greater than -18. Right? We understand that? And 5 divided by -3, okay, is going to be greater than 6 over -3. All right? We understand some of that whenever it comes to multiplication. Okay, multiplication, let's see, if C was greater than 0, okay, we'll just go ahead and make that a 3, okay, and A is less than B, which is this, then 5 times 3 is going to be less than 6 times 3, okay, or 5 divided by 3, 5/3 is going to be less than 6/3, which is 2, okay. The reason I don't like to give you real numbers is because I don't think in terms of A, B, C, right? I want to see, does this actually work whenever I plug in numbers? How does that actually work? Why does it actually work? Okay? And I can understand why something actually works whenever I go ahead and I plug in some numbers that fit those qualifications and then test it. All right, finally, we have what is referred to as the transitive property, which is if A is less than B, and B is less than C, then A has to be less than C. Let's go back and let's try that. You know what we said? A was 5, B was 6, and, let's see. If we say, if A is less than B and B is less than C, well, C would have to be something like 8, correct? Well, if 5 is less than 6 and 6 is less than 8, well, isn't 5 less than 8? Okay, right. I know it's like common sense, but just so that you understand where we're at. So all the properties above hold true for inequality symbols, whether it would be the same thing if we were talking about less than or equal to, greater than or equal to, and for some reason the book includes and greater to. So, but that's already in there. All right, does that we get that? A lot of what we're going to work with actually isn't even largely covered in some of the note sections. And I tried to put together some number lines, but that's not an easy thing to do with Smart Notebook. So I did my best that I could. They're pretty janky. Okay, so don't. Well, you can laugh at my number lines. I was laughing at them pretty hard. All right. So the solution of an inequality can be graphed on a number line, and I kept mine really simple. I've got my 0. I think on any number line you draw, you need to know where 0 is. I've got a -1 and a +1 because these are pretty simple. X is greater than 1, okay? But it's not equal to, which is why I have an open circle. And because it's greater than 1, I'm taking it to the right. And one of the nice indicators is that if I have my variable to the left, right, when I've solved it, my arrow should point in the direction that my inequality points. But if I ever get my variable on the other side, okay, that doesn't necessarily work, right? So if your variable is on the left and you're solved, right, your arrow on a number line should go in the same direction as your inequality symbol, all right? So x is less than 1, so we're at 1. It's an open circle because it's not equal to. Take my arrow to the left just like I see, okay? All right, we've got our greater than or equal to. I went ahead and filled it in. I probably should have used black there, but I like picking a different color, so all those things work. Notice that the symbols greater than and less than have open dots. Okay, since 1 is not part of the solution set, we don't include it, which is why it's open. Okay, The open dot is used to symbolize that all numbers, no matter how much smaller or how close to 1 they are, 1 itself is not included. So like 1.0001 could be included in our first example, but not 1. Okay? All right, the solid dot is used whenever we have our equal to signs to show that 1 is part of the solution set. Okay, but I feel like we probably already knew this. We probably have known this since the 7th grade. It's just a refresher, just a reminder. Okay. Then we have compound inequalities, which basically gives us the statement where we have and or the word or. Okay, and those are important as we'll look at later. And means both of these things are true, or means that it's either this or that. For instance, I'll give you an example of a graph of an and statement. An and statement on a number line is going to look, let's say we're dealing with 1 and -1, okay? And would look like that, okay? It's what we call a conjunction, okay? And, all right? A disjunction, an or statement, would look like this, okay? And you could fill in those circles if you wanted, but they're going to go away from each other. That's an or statement. X is less than -1, or X is greater than 1. Okay? So we have conjunctions and disjunctions. Okay? And means the set includes the intersection of the solutions of the two inequalities, or means the set will be the union of the solutions to each of the inequalities given. And may not even be written, but it would be understood. Okay? All right. And that's it for that. Take that back to the beginning, and let's pull open, not that, but let's find our Algebra 2, Lesson 10. All right. So we'll look at this first one, and then I want to pay close attention to number 2. On the first one, again, we start off by solving just like we would solve any equation, just as if there was an equal to sign there. What would be the first thing that you would do? Danielle? Distribute. Distribute what? -6 to the 3? Okay, so you're getting what? -18? Now what? Okay, and what do you get when you distribute the +6 or the -6 to the positive b? -6b, and you get less than or equal to -12. Axel, what would you do from there?
You take combine like terms.
Okay.
You add -18 to 12.
Add -18?
I mean +18.
+18. Okay, +18 to the 12. So -b is less than or equal to what? -12 plus 18. 4?
Yep.
You sure?
It would be 6, but it should be negative.
I mean it will be 6.
Okay, it's 6. Okay, and I think Eric's trying to make a point, but what? You think it should be a -6?
It should be -6b equals -6.
You said negative. Oh, you're right. -6b, because when we distribute, it's not. And you probably said it right. I just didn't write it down right. So we have -6b is less than or equal to 6. So I've got another step here then, right? John, what is that step? Divide by -6. Divide by -6. And so what's your answer? B what? B, he says B is less than or equal to -1. Is he correct? No, he's not. Why? Because I divided by a negative. Oh. B is greater than or equal to negative 1. B is greater than or equal to negative 1. All right, but that's, one, it's a good question because we see that B is less than or equal to negative 1 is the option B up there. We could have very easily made that mistake, right? That is probably one of the most common mistakes in solving inequalities, okay? So if you got to put it at the top of your homework assignment or whatever, you just got to learn how to make a mental note that, hey, I'm working with an inequality here. I need to pay attention to if I'm going to end up adding, or sorry, multiplying or dividing. Now, you can get so caught up in worrying about that, if you subtract across, somebody might change the sign. If we subtract across, do we change the sign? Okay, good. Good, you understand that. All right, this next part deals with something that we haven't yet talked about, which we looked at the number line, but we hadn't actually looked at like a coordinate graph, right? So we talked about, here, I don't even want to look at those. I want to look at this for a second, okay? This dotted line, all right, so a dotted line looks like that is less than or greater than. A solid line is what? Okay, so we're aware of that. Okay, good. Okay, so this next part, we know that it's going to be a less than or equal to. What we have to do here is we want to graph this. All I need to do is I need to come up with the equation for the line. Okay? Now, the equation for our line is going to follow the formula y equals mx plus b. Do any of us remember y equals mx plus b? Okay, what is b? The beginning point, it is also the y-intercept. So what is b in this graph? Negative 4. Okay, negative 4. All right. What is m? The slope. Now, keep in mind, we're not going to use an equal sign because we actually want an inequality symbol. But we need to find out what our slope is. So I drop 1, I go over 2, right? So my slope, I think Eric said it, is negative 1/2. All right, so negative 1/2 x. Now the question is my shaded region greater than my line or less than my line? All right, so he says greater than. Is there a way to test? What if I'm not sure? What if it's like, we get some like crazy looking graphs here where it's hard to tell if it's greater than or less than. Is there a way to test? How? Okay, this is what I want you to see. We're going to use what is called a test plot. Now, is 0, 0 part of the shaded region? Okay? What are the coordinates there? 0, 0, right? So this is x and this is y, correct? Okay? So because 0, 0 is part of the shaded region, if I plug in 0 for x and 0 for y, my greater than symbol should be accurate. So 0 is 0 greater than, and if I plug in 0 for x, that cancels it out, right? So I'm just wondering, is 0 greater than negative 4? Yes. Therefore, my statement is accurate. Y is greater than negative 1/2 x minus 4. Never heard of using a test plot? To me, does it help? It helps? Yeah. It takes the guesswork out of it. Now, let's say, if we had something where the 0, 0 wasn't part of it, what I would say is find a coordinate that is in the shaded region and plug in that x and y value, and whenever I get my inequality symbol to where it actually works, that's what I want. Okay? So pick a point that is in the shaded region. The nicest one is 0, 0 when it's in the shaded region. But if it's not in the shaded region, use a different point. Okay? You could still use 0, 0, but it would be confusing because it would have to not be true. Okay? All right, so I think we said what? Y is greater than negative 1/2 x minus 4, so A was our answer. Okay, let's look at some number line stuff. What, you guys are out of here at 36. So what's that? I think it's 36 and your next class starts at 39. All right, solve this inequality and we want to graph the solution set. Okay, so we already have this up here. We want to solve for C. What's the first thing you want to do to solve for C? Jewel? If you can't see it, you might want to pull it up on your screen there. It says negative, here, if I need to, I'll write it up bigger for you. Negative 8/7 C plus 4 is greater than or equal to negative 4. If I wanted to solve for C, what's the first thing I need to do? Subtract 4, very good. All right, so we're going to subtract 4 from both sides. Is that going to change the sign? No. Negative 8/7 C is greater than or equal to negative 8, correct? Okay, Allison, what would you do next? Okay, so you want to divide. You're correct from a standpoint that because this is multiplication that's occurring here, the only way to undo it is through division. But can I divide by a fraction? No, but what can I do? Multiply by the reciprocal. So multiply by negative 7/8. Multiply by negative 7/8, right? Okay, now, have I multiplied by a negative? So what's the first thing I want to think about? Flipping the sign, right? So what's negative 8 times negative 7? Actually, you should be able to determine, are these going to cancel out? And I'm going to be left with a positive 7, right? Okay, because I'd get positive 56. Positive 56 divided by 8 is 7. So C is less than or equal to 7. C is less than or equal to 7. I see that right here, don't I? Is that correct? Okay, let me check my little answer key here. That is correct. Now, there are a bunch of other questions listed down below here, but I want to make sure that you guys have some time to work and that you guys can ask me questions from your homework, right? I think you have 18 questions. That's not a huge thing to get done, but very few of you have your IXL diagnostic test done. So keep that in mind. I would like to be getting that here. I would love to have them by Tuesday, right? We have a long weekend. All right, so if you could get that done, basically here's what's going to happen. You just won't get points for it until you're done with it. So the quicker you get that done, the quicker I can give you the points for it. Okay? All right. And I'm going to be signing off.